Hello everyone, I'm back. I was not making many videos in a long time, and well, let's make a video finally. Today I'm going to show you some of my things here, and we're going to take a look at my modified DC arc welder basically. I mean, the original it was AC arc welder, but we was modified, or I was modified, so it's now DC, and I'm going to show it to you. It's right there on the table, and let's start. So, as you can see, we have now the arc welder in front of us. It's very small arc welder, relatively cheap from the hardware store basically. AC of course originally. I was modified, so I was make this full wave bridge rectifier out of two KBP C5010 bridge rectifiers, basically each rated for 50 amps at 1000 volts on this heatsink. Yeah, no, the heatsink is a bit small, but anyway, the transformer cannot operate continuously, so it doesn't matter. And it has a big, nice 120 millimeter cooling fan here. Yeah, basically, it is configured that each of the full wave rectifiers is actually a half rectifier. I don't know how to describe that, like a half of a rectifier. So two diodes are always in parallel. So normally I would connect the AC here and here, but I was connect only one AC here, basically the one of the transform outputs, and the other one it's right there, and then they are like linked together here and here, and that would be the positive, and this is the negative, right? Yes, I think so, yes. And I added these DC balancing choke, I think it's called, basically an inductor to make the arc more smoother. Otherwise, these are the original thermal cutouts for the transformer here and here. I guess this is the main cutout, and this is like a safety one if this one fails, because this is in the primary and usually the secondary overheats before the primary. Yeah, otherwise I was put a different switch in because the original switch was like a crappy type of like this switch basically from an outlet, or this extension outlet thingy. But actually this one is high quality. This one is from branch tool. It's made in Germany. This one is actually high quality, but this was like a cheap Chinese switch. And yeah, put this like nice rotary switch, or no, how you call it? I think it's a rotary switch. Correct me if I'm wrong. Is it rotary? Or cam switch? I'm not sure. It does just like, it's a nice sounding switch basically. A 3-phase one, but we use 2 of the 3 possible connections. Some vehicles down there, the best connector in the world, as we all know. And yeah, the neon indicator is now connected, so it actually illuminates when the transformer is running and turns off if the transformer is off on thermal overload. The original schematic was this, but slightly different now. I cannot see that one. Yeah. And now we will turn it on and we will measure the open circuit voltage and short circuit current at full closed magnetic shunt, and then at fully opened magnetic shunt. So the minimum and maximum current comes out of here at short circuit, and this is currently connected to my high power supply that I was built. Yes, it does everything that you can imagine. Well, of course you can always add things, but you know what I mean. Nice big Siemens disconnect switch on the front, a Chinese meter, but very good meter. The alarm, this is this one, but we will take a more detailed look at this in another video, and I will show you the backside because that's awesome. You have some in this one, it's some awesome stuff. You will want definitely to see that. Before we do that, I want to show some things here. So my nice big high voltage transformers, nothing compared to a microwave oven transformer. This is used for the this stand basically for the glass. I just put that now together because we will use my action camera. We'll record the arc. We will also make an arc with this graphite rod. Nice carbon arc basically. So yeah, that's my high voltage transformer, random microwave parts, cables, my two vacuum pumps, stuff, and of course we'll also make a bit of this. That's a nice full bridge that drives this high frequency ferrite core transformer. It's insulated in nice silicon oil. We will take a look at that in another video. And some stuff like circuit breakers, my toolboxes, chemicals like paints and others, and like solvents and stuff, and like plugs and stuff. And we have more stuff in this here, and here we have some instruments and other stuff. We will use some of those now. And yeah, my like UPS that I was to modify. If I find the photos, I will put some photos of the inside. I was to modify this one. So it has now, you can also turn off the backlight because that's annoying in the night, or yes. So basically it's annoying in the night, so I was modified there, so that's just the indicator. I was also removed that annoying beeper, so it just indicates with another LED if there's error or something. I added a circuit breaker to the battery because there was absolutely no fuse, very dangerous. And yes, you can use a normal AC type circuit breaker for DC up to I think 62 volts, this one, so the 24 volts are okay. That's a B32 amp. And yeah, some other electronic stuffs like router and how you call that one, I don't know, amplifier, and my gaming PC. But we can make any video of any of these if anyone is interested. So nice background from Microsoft website, very nice. This one, I like this one. So let's take a look at the open circuit voltage and currents and so on. I will just set up my meters and we will take a look at these. Okay, I was just set up my meter, and this is negative, this is positive. So cathode and anode, right? Yes. Let's turn on the power supply. Maybe you can hear the cooling fan going on, and let's turn on the transformers. Let's set it up to mains. That will be 230 in my country. That's about that. And let's turn on the arc welder. As you can see, the open circuit voltage is around 46 volts DC. And now we will make a short circuit and measure the current at fully closed magnetic loop, and then we will make a current measurement at fully opened, and then the carbon arc. Oh, before I make the current measurement, I forget to show the consumption at no load. As you can see, it's some 200 watts. That's actually a lot if you're considering, and that's 470 volt amps, and the power factor is of course terrible. And let's turn it off. Okay, I was just short out the output with this metal piece, and the clamp meter is set to amps, AC, and oh sorry, no, it has to be DC of course. My mistake, it's now to DC and fully closed magnetic shunt, again 230 volts applied to the primary. And the short circuit current is 32 amps. Okay, now I will pause the video for a moment and pull out this magnetic shunt. That will take a time. Okay, we are back, and I was now completely pull out the shunt, or almost completely I think, because I was limited so it doesn't go all the way out to not overload the 100 amp rectifier, because I don't want to push it to 100 amps. And now we will take again a measurement at short circuit basically. and as you could hear and see, it was 83 amps at short circuit. And now next I will set up the carbon arc and we will take a look at the arc. Okay, to just briefly show the setup, I put a one graphite rod here in this vise that I was actually weld because I was breaking basically. Put a ground clamp. Actually, it's not the original ground clamp because the original was not really quality. This one is more quality, and this one is original. And we will do it carbon arc at full open shunt, and I'm going to get my automatic welding helm, and I'm going to use the action cam now because this one is convenient behind this table at one welding glass. I don't know, welding glass I suppose. Yeah. Number 11. I don't know. Yeah, number 11. Sheet 11, and I will be back. I will edit those videos so that everything is in one piece. Okay, going now to use the action cam. Was taking some time to set this one up, something in the settings, and now it works. And we're going to make the carbon arc. I hope this has a sound, so yeah, good luck. Let's see. I was make the arc, and hopefully this was recorded, and I'm going to continue with my phone now. Okay, let's just make a bit of the carbon arc with the shading and the action cam. Had some trouble to set this one up, but it hopefully worked, and yeah, I think that's it for this video, and yeah, if anyone is interested, we could make a pattern of the light, and if someone wants to more about the carbon arc and see how about the illumination, because it's quite strong light, yeah, put it in the comments and then I will make a video. And yeah, oh, another project, we will do the famous, extremely dangerous microwave plasma flame at some point in the video, at some point in the future, probably in the summer, because I have to do that definitely outside, and now it's winter, so I don't want to do that in the outside now. But yeah, that's the filament transformer that I was rewind from a battery charging transformer, and that's the little cooling fan and magnetron noise and a wave guide. And yes, basically that's it, and that's I think everything. Maybe another look at the full bridge. 3-phase rectifier, we use only single phase, of course, for now, and turn off the power supply, and yeah, that's it for this video basically. Thank you for watching, and I see you soon again. Bye.